lesson, we're going to work with the multiplication principle. Essentially, we're going to see how you can draw out a tree diagram to help you with a counting situation. The tree diagram will lead us to seeing that you can actually use multiplication or the multiplication principle to count and calculate probabilities. Getting started with it, we've got a simple problem like here. Let's say you go buy some new glasses, Brenda. And when you go buy new glasses, you get to decide both the material and the shape. Now your frame can be made out of either a plastic or a metal. So you've got two choices for the type of material. For the shape of them, you can go with a rectangle, oval, cat's eye, or round. So with these, we want to create a tree diagram to help us list all the different options that you have when you're buying glasses. Well, when we're working with a tree diagram, and I'm going to start by putting in some of these lines in blue, and anything that I'm putting down in blue is not necessary to have written down for the tree diagram, but I'm putting them down to help you think. And I needed blue here. When we're looking at material, we've got two choices. It can be made out of plastic, or it can be made out of metal. After you've made that choice, you would have to make a second choice as to the shape that you're going to use. Essentially, this is creating levels within it, where we've got level 1 material, level 2 with the shape, and what we would actually wind up doing is splitting up and saying, after the plastic, what options do you have for the shape? Okay, you've got rectangle, you've got oval, and cat's eye, or round. If you did that with a metal frame, you have the exact same choices to make. Rectangular, or oval, or cat's eye, or round. By drawing out a tree diagram like this, we can actually see that we can follow these paths and create a list of all the different types of glasses that you would have available to you. You could have one that's plastic with a rectangular frame. You could have plastic with an oval frame, plastic with a cat's eye frame, plastic with a round frame. Listing the 4 different types of glasses that could be made from plastic, and listing the 4 different types that could be made with metal. In the end, you look at it and say, here is our list of the 8 different kinds of glasses that you could make. This piece actually serves as a really nice example, or a nice illustration of the multiplication principle. If we were not interested in creating the list of all the different options, if we only wanted to know how many options were available, we could look at it and simply say how many options were available for materials. 2 of them. How many options were available for a shape? 4 of them. And yet we wound up with 8 options in the end. And what would you do to turn 2 and 4 into 8? Just multiply them. That is the multiplication principle. If you have one event that can happen n number of ways, and another second event that can happen m ways, basically, if we're looking at it that if one event can happen 2 different ways, and then the second thing can happen 4 ways, just multiplying them will tell you how many ways that they could happen as a pair. How many ways could they happen together? And of course, it doesn't have to be just 2 events. If we wanted to put in a third option for the color of the material, if we wanted to have like black or blue or pink or brown or whatever, we could add color to this and say that would be a third option, which would give us just a third piece of multiplication. If we wanted to put in things like, are they tinted lenses or non-tinted, we could add a fourth level. And it's still based on multiplication. So, really simple. We're going to roll 2 dice. How many different outcomes are possible? Well, of course, we are looking at it and saying on dice number 1 and dice number 2, how many different things can you get on dice 1? 6. How many can you get on dice 2? 6. So all we're looking at then is saying event 1 is 6, event 2 is 6. To get the number of different pairs, we just multiply 6 times 6, and we would get 36 different options, or 36 different pairs. And if we really wanted to, we could create a tree diagram and create the list of the 36 different things that could happen, but we don't need the full list. Not for this problem. For this one, we only needed to know how many. This type of technique can also be used to calculate probabilities. For instance, you go out to your lockers in the hall. The dial that you have has 40 numbers on it. And you know that it takes 3 numbers in the correct order to get your locker open. Well, if somebody were to just randomly guess 3 numbers, what is the probability that you could randomly guess 3 numbers and open a locker? Well, this is one that there are 2 things going on. First of all, we know that the probability of a correct combination, we know probability from our previous work is the number of successes compared to the number of possible outcomes. How many successful combinations will open your locker?
Every time.
Just the one. You have to have all 3 in the correct order. And so to finish off our probability here, we need to figure out how many different combinations, how many different orders can you actually put in. And of course, in order to do that one, we're thinking you've got the first number multiplied by the second number multiplied by the third number. For event 1, event 2, and event 3, Brenda, you correctly identified each one of those things has 40, 40, 40. And when we multiply 40 times 40 times 40, we get 64,000. So the probability of somebody guessing your locker combination, 1 in 64,000. And thus we can see this multiplication principle we can apply to count how many different ways things can happen. We can use it to calculate probabilities. But it is not very helpful if you are trying to create a list of the different things that can happen. If you actually want a list of things, the multiplication principle is not particularly helpful. There are instances where a tree diagram can actually be more effective, especially if you start looking at some kind of weird situations.